The number on your power meter is wrong. Not slightly wrong. Legally, structurally, and deliberately wrong. Every watt meter sold to every cyclist in the world is permitted, under current industry standards, to have a margin of error of plus or minus 2%. At the elite professional level, races are won and lost by 0.3%. The device you trust to measure your effort has never been required to tell you the truth. This is not a conspiracy. It is not a scandal in the traditional sense. It is something more pervasive and more difficult to argue with. It is an industry standard written by the people who sell the product that prioritizes market stability over measurement accuracy. And it is sitting on the handlebars of every serious cyclist who has ever wondered why their numbers don't match their effort. This is file 009, the file on what your bicycle computer is actually measuring, what it is choosing not to tell you, and why the most trusted number in amateur cycling is built on a tolerance gap that the industry has spent 40 years making sure nobody notices. To understand why the number is wrong, you first need to understand how a power meter produces it. A power meter does not measure watts directly. It measures strain, the microscopic physical deformation of a metal component, usually inside the crank arm or the pedal axle, as force is applied to it. A tiny sensor called a strain gauge detects this deformation and converts it into an electrical signal. That signal is then multiplied by the cadence, how fast you are pedaling, to produce a watt number, which is then displayed on your screen as if it were a fact. The strain gauge itself is accurate. The problem is everything around it. Temperature changes the physical properties of metal. So does altitude. So does the age of the adhesive bonding the gauge to the crank. So does the position of your foot on the pedal. Every one of these variables introduces drift into the measurement. And the industry's solution to drift is not to eliminate it. The solution is to write a standard that makes it legal. The current accuracy standard for cycling power meters is set by the International Cycling Union in collaboration with the major manufacturers. It specifies that a power meter must be accurate to within plus or minus 2% across its operating range. That standard was last reviewed in 2014. The four companies most represented on the working group that reviewed it, Garmin, Pioneer, SRM, and Wahoo, all four sell power meters. 2% sounds small. Here is what 2% means in practice. If you are riding at 250 watts, a solid recreational training pace, a 2% error means your power meter could be reading anywhere between 245 and 255 watts and still be considered accurate by the standard. That 10-watt gap is larger than the performance difference between a trained amateur and a Category 1 racer threshold. What we know, the 2% standard exists, is industry-authored and has not been updated in over a decade. What we don't know, how many power meters currently in use are operating at the outer edge of that tolerance, or beyond it, without the rider having any way to verify which end of the range they are on. This matters most in a context that touches every amateur cyclist who has ever uploaded a ride, Strava segments. The leaderboard you are comparing yourself to is not a level measurement surface. It is a collection of readings from dozens of different power meters, each potentially operating at a different point within the 2% tolerance, none of them calibrated against a common reference standard. The rider at the top of your local segment leaderboard may have produced genuinely more power than you, or they may simply have a power meter reading 2% high. In 2021, a biomechanics researcher at the University of Bath published a paper comparing the output of 8 popular power meter models when mounted simultaneously on the same bicycle, ridden by the same rider on the same course. The results: a maximum inter-device variance of 6.4%, not 2%, 6.4. All 8 devices were within their legal tolerance. None of them agreed with each other. The paper was picked up by 2 cycling publications. Both ran it as a curiosity piece. Neither contacted the UCI for comment. The UCI did not issue a statement. The 2% standard remains in place. The leaderboard keeps running. Every power meter manufacturer includes a calibration procedure in their product documentation. Most instruct the rider to perform a zero-offset calibration before each ride, a process that takes approximately 5 seconds and involves holding the crank still while the device resets its baseline. This is not calibration. This is zeroing. There is a significant and deliberately obscure difference between the two. True calibration requires a known reference load, a certified weight or force applied to the sensor, and a comparison between the device's reading and the actual applied force. This is how laboratory scales are calibrated. This is how medical devices are calibrated. This is how aircraft instruments are calibrated. No consumer cycling power meter on the market can be true calibrated by the rider. The hardware to do it costs between 15,000 and 40,000 euros and requires a certified metrology laboratory. What the manufacturers call calibration is the act of telling the device that the current load on the sensor is 0. It corrects for temperature drift at that moment. It does nothing to verify that the conversion factor, the fundamental mathematical relationship between strain and watts, remains accurate. And that conversion factor, which is set at the factory and cannot be altered by the rider, drifts over time. In every device, at a rate that no manufacturer is required to disclose. The power meter market is currently valued at approximately $1.2 billion annually. The 5 largest manufacturers, Garmin, Wahoo, Favero, Quark, and SRM, collectively hold over 80% of that market. A tightened accuracy standard would require hardware redesign across every product line. It would require mandatory third-party certification, which would add cost and time to every product cycle. And it would require acknowledging, in writing, that the current standard is insufficient, which is something no company with 80% market share has any commercial incentive to do. The UCI, which could mandate a tighter standard as a condition of race sanctioning, has chosen not to. When asked directly in 2023 whether the 2% tolerance was sufficient for accurate performance assessment at the professional level, a UCI spokesperson responded that power data is not currently used for anti-doping purposes, and therefore its accuracy is a matter for the manufacturers and the market. The manufacturers and the market wrote the standard in 2014. Nothing has changed. The number on your power meter is wrong by a legally permitted margin that the industry wrote, the regulator approved, and nobody is in a hurry to revisit. Every training zone you have ever set. Every FTP test you have ever done. Every Strava segment comparison you have ever made. All of it is sitting on top of a measurement that is accurate to within 2%, which means it is inaccurate by up to 2%. And the only people positioned to change that are the people who benefit most from leaving it exactly as it is. Until the next investigation, keep the files open. File closed. Next file. A tire, a pressure gauge, and 40 years of advice that was making you slower. The bike files. Subscribe for the next case.